Right. So the title of the talk I'm giving today is Dynamics of Retraction in Science. Though we'll see it's kind of about retraction of ideas a little more broadly than that. And this is collaborative work with two people. So Travis Lacroix is a graduate of my department who's now doing two postdocs at University of Toronto and a machine learning institute in Montreal, and Anders Geil, who is a computer science graduate student. And let's start with a little example. So Scott Rubin is the first author on this paper. He used to be a very influential anesthesiology researcher. The details of this particular study don't really matter very much, but what matters is that this, along with 20 other articles, were retracted in 2010 for fraud. So Rubin had fabricated data in this set of studies. 4 years later, a group of researchers looked at these studies and found that over half of them were still being consistently cited in the scientific literature as accurate. And this sort of failure of retraction, where things are retracted but continue to be cited very widely without any seeming knowledge that they have been retracted, has actually been widely observed across scientific communities. So retracted papers are often cited at the same rate as they were before retraction, and different studies looking at how they're cited have found that only a very small percentage of them, often between 5 and 10%, mention that a retraction happened. So we see a lot of these straightforward citations to the original research. So what we were interested in this project is, there's another kind of retraction that I'll just mention, which happens more in the news media. So here's an example that was published a few years ago. Kids are growing horns from too much cell phone use. Now, this appealed to some scientific study looking at bone spurs on the back of necks from bending down from cell phones. It wasn't actually a good study. And within a few days, sort of all over the internet, were responses to these widespread reports about kids' horns saying like, no, this isn't right. So this is another kind of retraction. And another kind of retraction where we think that often afterwards you see sort of mistaken beliefs, many people sort of continuing to believe the original thing. So we were interested in this project and asking, why do people continue to hold false beliefs that have been retracted and reversed? So why is this true even in science, where everyone holds these explicit aims to develop good beliefs? And then more generally, what are the dynamics of retractions and the spread of retracted information? And can that help us understand this first question, why retractions fail? So in this project, we use agent-based modeling methods, and we draw on some empirical findings to try to think about this phenomenon. And we thought this would be a kind of nice place to use agent-based models to supplement the empirical data, because it can be hard to get a handle empirically on who in a network believes exactly what, when, at what stage. So hopefully models can fill the gap a bit. And as you'll see, the kind of models we present are very simple, but we hope they can direct sort of further empirical research, thinking about the dynamics of retracted information. So here's a roadmap for the rest of the talk. So I'll start by giving a little background, talking about some empirical work on retraction in science. Then I'll introduce a modeling framework that we'll use throughout the rest of the talk. And then I'll go through a few sets of results where we look at various models to ask, okay, what happens? How might retraction work under different situations? So that's parts 3 and 4. And then last, if I have time, I'll relate some of this work to what's been happening with scientific retraction during the COVID-19 pandemic, and especially the interactions between the scientific, journalistic, and social media communities during the pandemic. All right. So some background. So what we're really interested here is not just the, sort of retraction of scientific papers. We're interested in a broader phenomena. You have newspapers retracting claims. Sometimes something gets published in Science and it's not retracted, but peers offer an extremely thorough critique. So we no longer think that idea is viable. You see popular science articles that prove previous claims wrong. So what we're really interested in is factual claims that spread socially, where at a later date it becomes known or widely accepted they're wrong. So it becomes kind of incontrovertible that this thing we thought is false, but you see the original belief persisting. So that's the thing we're really modeling and thinking about here. Now, it can be tricky to get data about such processes. So here, in talking about the background for them, we rely on data regarding retraction and citations in science, this more narrow phenomenon. And we're taking citation to indicate that the retraction of a false idea isn't working. And of course, when you cite something that doesn't exactly track your beliefs, but given norms of truth-telling in science, we take this to be a kind of okay proxy for what's really going on vis-a-vis the spread of false beliefs and their persistence. So the basics in this empirical literature are that there are reasons things are retracted. So you have errors, fraud, failures to replicate. Error is the most common reason for retraction. Rates of retraction have been climbing steadily over decades. And then study after study have supported this claim that retracted papers continue to be cited, often at a very high rate, often for years and years after they're retracted. Now, it seems like in large part, what's going on is these retracted papers, ideas, and beliefs are being shared by people who don't know that they're wrong. So people aren't thinking this is false and I'm going to share it anyway. Instead, there are social processes underpinning this spread and sharing of ideas that can elucidate why these false beliefs are persisting and continuing to spread after they've been refuted. So how do we go about exploring these processes? Well, we start with a modeling tradition from the social sciences. So one kind of old idea in the social sciences or tradition involves thinking of behaviors and beliefs as similar to viruses or contagions that can spread in social networks. And the models used to do this are sometimes called network diffusion or network contagion models. So the idea is you model a belief like the world is round, or a behavior like eating mushy peas with fried fish as something that can diffuse or spread between people who have some kind of social or communicative contact with each other. These kinds of models aren't good for every kind of idea. And if people would like to discuss in Q&A what sorts of things they apply to, I'm very happy to do that, but they do track some sorts of beliefs quite well. So your model might look something like this. You have some network structure. Each node is supposed to be an individual. Each edge is some communicative or social connection between them. And then over time steps, some variant or idea can spread from a source to others connected to them, and then to their neighbors and further through the network, etc. And people have looked at many, many different versions of this kind of model. So you can vary network structure, you can vary how the rules for how ideas spread, you can vary rules for innovation, where new ideas come from, you can make some nodes more influential than others on their neighbors and some less influential. So there are a lot of things you can do with this kind of model. All right, so with that, let's move on and discuss our particular models that we looked at here. So we wanted to first develop a basic model that could provide some insight or way to start thinking about failures of retraction. And to do that, we started with a key idea, which is that there's often an asymmetry between novel ideas and retraction for the following reason. So it's often conversationally appropriate to share novel ideas, whereas retractions are less apt. And if people are familiar with, Gricean norms, this relates to the idea of relevance. So when people are talking to each other, they tend to share information that they think will be relevant or interesting to the people they're communicating with. They tend not to share information that they think will be irrelevant or uninteresting. And so novel scientific ideas often are considered interesting on their own. The fact that some idea has been retracted is typically only interested if you have some reason to think the person already knew about that idea in the first place. They'd already heard about it, maybe they'd been exposed to it, maybe they started believing it. So we instantiate this in the model by supposing retraction spread to nodes that already hold a false belief. So basically, they will spread in areas of the social network where the false belief has already become relevant. So just to give an example, if we go back to that cell phones and horns study, you're probably more likely to say to someone, did you hear that cell phones can give kids horns? Than to say to someone, did you hear that cell phones don't actually give kids horns? The person would say, why would I have thought they did, right? Okay, so the base model then looks like this. We have a set of nodes connected by edges. So these are representing individuals in a network. They have 3 belief states. So they can be in an uninformed state. They've never encountered some new belief. They can be in a false state. They've encountered a false belief, or a retracted state. They've seen that that belief was retracted. They all start with neutral beliefs. So we say they haven't been exposed to this new idea that cell phones give kids horns or whatever it is. Then we introduce a false belief to the model. We introduce the fact that it's retracted. That can happen at the same time or later, as I'll describe. And then we assume that there's sort of random interactions among connected neighbors. So people talk to or interact with those in their social networks, and these beliefs can spread. So if you hold a neutral belief and you encounter someone who holds a false belief, they can tell you, did you hear this thing about cell phones and horns? And so that can spread through the network. If you've heard about the cell phones and horns and someone tells you, oh, it turns out that wasn't true, that was a bad study, that retraction can spread to you. Any questions about that base model? Okay. So here's a little image of it. You know, the colors here represent neutral, false, and retracted. For the very first things I'll talk about, we'll talk about a fully connected, complete network, and then I'll move on to different network structures. So we pop a false and a retracted belief in there. And then, you know, in each round of simulation, we randomly pick 2 interactors. The false belief can spread to the neutral one. If we randomly pick these 2 interactors, we assume this person who hasn't heard anything about these beliefs isn't going to be interested in the retraction, or this person won't share anything about that with them. So nothing spreads. If people hold the same belief, nothing happens. But if someone who knows about the retraction meets someone who holds a false belief, they can spread the retraction. Okay, so the kind of first base results from this model are that there are no stable states where agents hold false beliefs. So good, we solved that problem. Okay, that's not going to be true in every version. But in this version, since they're all connected to each other, all the false beliefs are eventually going to be converted to retracted beliefs. So eventually someone will meet someone who holds the retraction, and they'll adopt the retracted belief if they're currently holding a false belief. And then the stable final states of the model include some combination of neutral and retracted beliefs. So some people have just never heard about this thing. Some people heard about it and eventually learned the correction. And across different versions of this model, you can see actors holding false beliefs for different average lengths of time. You can see more or fewer people ever having held a false belief, depending on different variations. So for example, this is an image sort of showing the dynamics over time of what happens in this kind of population. So over time steps, we see this going up. We see everyone starting with neutral beliefs and then 1 false and 1 retracted belief. The false belief starts to spread. Neutral beliefs start to disappear as more and more people gather the false belief. Once the false belief becomes prevalent, the retracted belief starts to spread, and eventually you end up with most people holding the retracted belief and some people who never heard anything about this at all. One little thing we find is that the larger the population, the more the false belief can get a grip. Basically, because when you have more individuals, the chances that the false belief gets stamped out sort of early on are probabilistically quite low. It's probably going to kind of get out into the population and spread around for quite a while. So if we compare a population of 10 with one of 1,000, over here, we see the neutral belief kind of dying off, the false belief becoming quite prevalent before the retraction starts to chase it and eliminate all those false beliefs. All right, so that's the kind of most basic version of the model. So let's talk about making this a little more interesting and a little more relevant to the world. All right, so in many cases, perhaps almost every case, retraction doesn't occur immediately. And the first sort of thing we ask is, well, what changes when retraction is delayed? So often it takes years before a scientific paper might be retracted if it fails to replicate, for example. And the answer is that, well, the false belief states are held for longer on average, but not as much longer as you'd think. And the reason is that when retractions are issued later, they tend to spread faster because they're more relevant to a bigger group. More people already hold the false belief, and so more people care about the retraction. So if we imagine, the same model where we allow people to interact and the false belief to spread for a while before we introduce the retraction, now when the retraction pops up, it's relevant to all of these people instead of just the one person it would have been relevant to at the very beginning of the model. So here are some results from models like this, where on the x-axis, we delay the retraction for more and more time in the model. And on the y-axis, we ask, well, how long on average do individuals hold false beliefs? And for quite a while of delay, you see basically no change in this average holding a false belief. Though eventually, if it takes a very long time to retract the information, you see people holding false beliefs for a longer time. And that's basically because in this whole regime, when you're introducing the retraction later and later, it's going faster and faster through the population once it's introduced. Okay, so now let's get to a model that I think is the first kind of actually interesting one. So we add this supposition. Actors don't share new information indefinitely. And this is somewhat realistic. So you get a new belief, you don't walk around telling people about it forever. You share it for some period of time where it's still in your head, it's still interesting to you, it still seems kind of relevant to the community. Eventually, you stop just bringing it up and telling other people about the cell phone horns thing or, this paper you heard about or whatever. So we ask, what happens in the model if we now just have actors share their new belief for some number of time steps? So maybe for 50 time steps, if they meet someone, they share their new belief. And then after that, they no longer share a new belief. And the answer is that in this, quite realistic change, now you have false beliefs persisting indefinitely in the model. So sorry, let me just see where I am here. Yeah. Okay, so now we see this finding that you never have stable false beliefs. It's kind of an artifact of the way we set it up. Suppose we're here in the model, we see the false belief has spread some, the retracted belief has spread some, but nobody for some number of rounds gets paired who's going to share the false belief or the retraction. So we see random pairings for a while where no one has anything interesting to say to each other. Eventually, these people are going to stop talking about their beliefs, and the belief state will just get stuck, and nobody's updating on this anymore. And I think that while this is a simple model, there's something kind of realistic about it. So we sometimes hold false beliefs, and by accidents of history, we just aren't exposed to knowledge that they're false. And then they just kind of stick around as latent false beliefs that we continue to hold for a long period of time. And here's something interesting we find in these models. We ask, what happens when people share for a very short period of time, for longer periods of time, for very long periods of time. And we find that kind of intermediate sharing lengths lead to the greatest level of stable false beliefs. So in these kind of regimes, the false beliefs get going, but the retraction kind of times out before there's enough general false belief to generate interest in it. So if we look back at these kind of dynamics in the model, here we look at different parameters where they share from a very short time frame to a very long time frame. So over here, the model looks like the base model where everyone shares their beliefs forever. The false belief gets going, then the retraction gets going, and it basically, eliminates the false belief. if nobody shares things for very long at all, they don't share long enough for any of these beliefs to start spreading. They hear about it and they basically never get a chance to tell anybody. If they share a little longer, the false belief kind of gets going a bit. So the person with the false belief meets some people, tells some people about it, it spreads some in the community. But the retraction isn't that relevant at the beginning when someone finds out it's retracted. So they never really meet the right people to start sharing the retraction. So the retraction goes nowhere. And then eventually, if you get to a long enough sharing time frame, the retraction is shared long enough to become relevant and get shared as well. But so these intermediate stages are the ones where you see these very high levels of false belief, where because it's relevant, it's shared for a while, but the retraction isn't relevant during the time period where people would be sharing it. Does that make sense? Are there questions about that? Okay. So to summarize that, here's a figure where we increase this sort of how long people are sharing the belief. And we ask at the end of simulation, on average, what beliefs do they hold? And when it's a very short period of time, everyone kind of holds neutral beliefs. When it's a very long period of time, everyone knows the information was retracted. And in the middle, they tend to hold false beliefs at the end of simulation. All right. So we also sort of combine these two elements. And because retractions are dependent on the level of false belief when they are issued, we find that in some cases, the network actually does better when you delay the retraction. So this basically allows the group to get to a state where the retraction is interesting, where it gets some traction in the community. So it allows you to get to a state like this, where everyone's holding false beliefs, and then you issue the retraction and everybody cares about those false beliefs. And again, I think this, it's not going to be realistic in every case, but there are realistic cases like this. So cases where retractions are very widespread and successful are often cases when a belief was like very popular or widely held. Some scientific belief was like very well known. So I'm thinking about things like power posing, which was this kind of big psychological finding. Also, the retraction got a lot of attention. So here's a figure kind of describing this. Now we have some time frame for sharing. People stop sharing after some period of time. And then we ask what happens when we delay the retraction further and further. And basically, the longer we delay the retraction, the greater the proportion of the population that holds retracted beliefs at the end of the community. And the fewer and fewer people hold false beliefs at the end. So that's a kind of a counterintuitive finding or surprising finding. And I'm not saying like run out and tell everyone like don't retract ideas right away, but it's something worth thinking about. So takeaways from this part of the talk, under realistic conditions, we see one reason why false beliefs might persist. So you sometimes have a failure of actors to communicate in this scenario of social sharing of information, and it just leaves some older beliefs straggling behind. So just accidents of history because of how we share information socially. And then in addition, we had this sort of counterintuitive finding that the more prevalent a false belief is, the easier it might be to retract it actually. Okay, now let's look at a few other versions of the model focused on thinking about the location of where a retraction happens. So who introduces the information that something has been retracted in a social network? So to this point, we've been considering this very trivial network structure, this complete network. And further questions might ask, under more realistic network structures, do the same observations hold up? And then also we want to ask, in these non-trivial structures, how does the location of retraction influence outcomes? So how does the place something gets retracted matter? In the previous model, the location of the retraction didn't matter because everyone's just connected to everyone else. So every location in the network is in some ways the same. All right, so the first thing I'll describe that we looked at is small world networks. So many human networks have been shown to have small world properties. These are networks that tend to have clique structures where if I have a friend and they have a friend, their friend tends to be my friend. So people group into cliques. And then they tend to have short average path lengths. So this is the kind of 6 degrees of separation idea, that people have short paths between them and anyone else in the network. And we found in these kind of models, all the qualitative results that I've described are replicated. So all these things about delaying retraction, about timing out how long you'll describe things, are the same. And then we also looked at models where we would compare situations where the node that originally introduced the false belief also introduces the retraction, or else we just pick some other random individual to introduce a retraction. And we found that if we just pick some other individual to introduce the retraction, on average, we had more false belief in the end. So they do better when the originating node describes a retraction. And the reason for this is basically, if, say, I've originated a false belief, it's sort of spread out from me among my social ties, more people who are closely connected to me are going to hold that false belief. So when I then retract it, the retraction is going to be more relevant to the people who are in my kind of area of the social network. If some scientist in some other field says so-and-so in philosophy is wrong, it's probably not going to be as relevant to the people they know, and it's going to get less grip in the network. So this is summarizing these results. This is over many different delays in retraction. And here is what happens when the original retractor the original false belief person issues the retraction versus a random person. Across all of these situations, there's more false belief when the random person does it than the original person. And that's stable across, all different versions of this model that we look at. All right, so another kind of different structure we look at are preferential attachment networks. So this is another important feature of many real human networks, including ones in science, are called scale-free properties, which means that of all the individuals in the community, a few of them are very highly connected. Most of them are not very highly connected. So basically, some of them you think of as more influential, as in connected to more other individuals. So we also built preferential attachment networks to look at these same sorts of questions. Again, the sort of base results held. In these networks, we asked, okay, what happens if a central node issues the falsehood? So someone influential issues the falsehood, and then the retraction either comes from them or one of the more peripheral nodes, someone who has fewer connections. And again, we found retractions, unsurprisingly, were much more effective when issued by a central node, because again, this individual is connected to more people who have heard the false belief from, issuing out from them. And also in this case, they're more influential in general. So we actually, later I was like, this wasn't a great model because there were sort of two causes at play in why, one kind of retraction did much better than others. So we got a kind of replication, though, of this idea that you do better when the person who originated a false belief also retracts it. And then we also looked at homophilic networks. So when it comes to scientific networks and to more general ones, this is again a sort of typical property. And it's a tendency for individuals in a group to be disproportionately connected to in-group members versus out-group members. So we might see this within a scientific field. If you have psychology and biology, you'll see homophily between people within the fields compared to across them. You might also see it in real world networks when it comes to things like social identity groups, like, Black people and white people in one city. You see it also with conservatives and liberals on social networks. I just threw out this picture to be like, here's a little picture of homophily. Okay, so when we, looked at these dynamics of retraction in homophilic networks, we found that generally ideas spread slower, and this reflects previous findings about the spread of belief in homophilic networks. That in general led to longer persistence of false beliefs and greater levels of stable false belief than in some other kinds of networks that we looked at, for example, just random ones. And then again, oh, sorry, and this illustrates this. So in homophilic networks, the sort of path length between individuals can often be longer because they can be in these different groups. So if you're thinking about a situation like this, where the false belief is issued in one group and then someone issues a retraction or a refutation in another group, there's a long path length between them until the false belief starts to become relevant to the people who might hear about the retraction. So we looked again at, where the retraction happens and how that matters. And in particular, we asked what happens when it's retracted in the original group where someone made a false claim versus the other group. And we found in general, retractions are less successful when they're made in the other group, which shouldn't be super surprising. Again, it's this effect where a retraction is made in a place where it's not that relevant to people. And then we also find that if you have a group where the false belief but not the retraction is issued, they tend to do quite poorly. So if someone makes a false claim in this field and someone else refutes it in this field, these folks do quite badly. They have quite a lot of false belief because it's harder for the retraction to ever get to them. All right, so takeaways from all of these models: network structure matters. It may increase the persistence of false belief because sometimes you have these longer path lengths in less connected networks. And retractions do best across basically all the cases we looked at when they're issued at the location the false belief was issued. Okay, so last bit, let's see. Retraction and COVID. So there have been a bunch of things related to the pandemic that have made retraction and failures of retraction highly relevant. So first of all, researchers and journals are publishing very quickly on scientific findings with less vetting than usual. And this makes sense because everyone wants to know about COVID, but we're seeing a lot of scenarios where researchers are publishing preprints or posting preprints, or journals are publishing articles within just a couple weeks of their submission. And they maybe haven't undergone as much usual vetting, peer review, and feedback as they would undergo if we weren't in a pandemic, right? So that's happening quickly. Then you see members of the media who are under enormous incentives to quickly publicize COVID-related findings. So you see more scouring of preprint archives, more people checking for the very latest sort of COVID findings, and then everyone kind of very quickly publishing in standard media about these findings. So we have this sort of situation where information is going faster and with fewer checks than usual about new scientific findings. Third, these findings are often highly relevant to life and death decision-making, both for individuals and policymakers. And then fourth, a startling number of high-profile findings have been reversed or retracted. I should say in the last year now. I wrote these slides a while ago. And so we're in this situation where retraction is happening more and where it's more important. And so failures of retraction have been quite notable and relevant. And so now I want to kind of connect this up. I haven't said much about disinformation here, but I want to connect this up. We're talking about now this process where you see false information being spread on social networks. It's quite relevant to people's lives. It's often continuing to spread after it's been shown to be false. And it's part of this kind of dynamic of social sharing and failures of retraction related to social sharing. So I'll give an example. Actually, you know what? Let me skip this example and do the other one, which I think is more interesting. So I'll give an example of how this has happened during COVID and then draw some morals for this bit and the talk. So this was an article that was posted like late last spring, early last summer. It was a study of the prevalence of COVID-19 antibodies in Santa Clara County, California. And so they tested people for antibodies. They concluded that a large number of people had antibodies, many more than had gotten positive COVID tests. And on the basis of that, they calculated the infection fatality rate for COVID and claimed that it was low, that it was similar to seasonal flu and much lower than other people thought it was. Now, very shortly after they posted this preprint, it was pointed out, especially on Twitter and by many other academics, that they had made a mistake basically in how they propagated the error rate for their test into their estimates. So they replaced that with a second preprint with corrected numbers. Now, there were a number of other issues with the study, but I won't go into that now. I'll just focus on this correction. So their original estimate was that the fatality rate was between 0.12 and 0.2%. When they revised their paper, the implied fatality rate was between 0.11 and 0.4%. So the upper end here doubled. So now with the new revision, they were estimating that COVID could be twice as deadly as they had originally claimed. And furthermore, this uncertainty interval now overlapped with other estimates of COVID fatality rates, like that made by the WHO and a sort of influential German study. But around the time the preprint was posted, Andrew Bogan, so one of the authors on the paper, posted this in the Wall Street Journal opinion page. New data suggests the coronavirus isn't as deadly as we thought, using the original numbers. This was picked up by news media around the world, every major news source in the US, but many also elsewhere. And so it got spread very, very widely. Now, after they fixed the preprint, this opinion article was never retracted or fixed, and it's still up there in the same form, claiming that the fatality rate is between 0.12 and 0.2%. Furthermore, this headline isn't correct anymore because with the fix, it's about, the deadliness is within the range that other people were calculating, right? Furthermore, even after the preprint had been fixed, this Wall Street Journal opinion article was being promoted on Facebook for months. So we see a situation here where we had this original research mistake, it was fixed, but once it started going in the social network, and this now included in traditional media and on social media and spread in these many different ways, we saw the falsehood continuing to spread well after the fix was made. So I think this is kind of an example of the sort of scenario we're talking about where, the retraction isn't reaching certain nodes and so isn't pushing on forward. And then it's exacerbated by media practices. All right. So we labeled under the sort of COVID-19 example, we sort of came up with a name for this sort of phenomenon that we've been calling information zombies. So basically, these are ideas that ought to be dead, but keep shambling about the internet causing problems. So they can be scientific ideas that have been retracted. They can be claims in news media that have been entirely refuted, but they seem to be undergoing some of the dynamics that we look at where they continue to spread, even though somewhere in the network, someone has said, wait, these are just, uncontroversially wrong, right? And I'll just point out that this kind of false information, an information zombie, importantly, in many cases, doesn't resemble typical misinformation. And this causes problems. So they're not unfounded rumors. They're not active. No one's trying to misinform anyone. It's not disinformation. They're not conspiracy theories. They're ideas with scientific legitimacy. They come from legitimate sources. They reflect attempts at truth-telling. But after retraction or refutation, they don't die. And the issue here is that all of these features of them mean that they're very hard to detect using, for example, algorithms tuned to misinformation and disinformation, because they just look like scientific information. And they're very hard for individuals to detect as false information because they just look like scientific information. They look like completely legitimate information. So this, we think has contributed basically to misinformation during the COVID pandemic, especially this kind of, retracted information dynamics. All right, so to sum up, retractions can fail because of these dynamics of information spreading in humans, given that we learn socially. Sometimes we just fail to encounter retractions after we learn false beliefs. Second, we argue there's this asymmetry between novel claims and retractions that may help drive this failure. And that's something that we'd like to look more empirically at and see how much that's true and how much that is in fact driving failures of retractions. Third, widely held false beliefs paradoxically can be easier to retract since the retraction is widely relevant when it's introduced. Fourth, location of retraction matters, and it's most successful when issued by individuals who issue initial false beliefs. So that's quite relevant to thinking about cases where one news outlet points out that someone else was wrong, or someone posts in another journal that another scientist was wrong. Maybe it's then incumbent on the source of original false information to reshare information about retraction. And then fifth, during the COVID-19 pandemic, failures of retraction seem to be especially problematic or especially common or just something that's been happening a lot. And with that, I will say thank you. That's the horn, by the way, the cell phone horn.
Thank you so much, Cailin. That's wonderful.
Yes, so open to questions.
Before there are any questions coming up, I was wondering like how the issue of trust and the authority of speakers, how do those play in the sort of the persistence of people still believing the false beliefs? And I'm thinking of Andrew Wakefield, who he's still has such a mass of adherents and that kind of feel that they've been whatever, that they are not cared of, or they've been judged or infantilized or something. You lose the trust in the medical consensus, as it were, in the authority of science, and it's easy to sort of wrap up towards a different community because you think that you are more respected or your concerns are taken more seriously or things like that.
Yeah, so and I'd point out with the Santa Clara study, Ioannidis, who's one of the authors on that paper, is also a very popular, very trusted academic has continued to spread this idea that the fatality rate of COVID is very low compared to what other people have been estimating. And that I think has actually been tremendously impactful on individual and policy decision making. So I think trust is extremely important in the spread of beliefs and when people actually pick up beliefs and adopt them. Of course, in this model, we completely ignore that factor. We just assume that people are willing to adopt beliefs from anyone who they meet, who they have a social connection from. And so you could think of this as a kind of extreme simplification of a reality where in many situations, people who were hearing things from others in their social network would actually be unwilling to adopt them, right? They'd be unwilling to pick it up. And so a more accurate model might include situations where people were resistant to certain beliefs coming from different places or resistant to some others sharing them.
No, that is quite complicated when you look at the trust and affinity and how people arrange their claim.
I mean, we also completely ignore in this model the fact that people care about the details of beliefs in many cases in deciding whether to pick them up, that they have confirmation biases so that if a belief fits with other things, they already believe they're going to be more likely to adopt it. And we don't have any resources where we model something like, what do they already believe? Does this new thing fit with that? Would they be willing to accept it on the basis of that? So there's a lot of things missing about the real process of belief spread. And what we say in the paper is something like, you only want to be applying this model to very specific cases. And these are cases where a belief that's spreading is not in some way political, or it's not connected up with a lot of other firmly held beliefs. It's something like facts, factoids, new information popping up. I mean, another example that I could have given is one where you saw this claim that COVID had been engineered using HIV, which spread quite widely and was retracted almost immediately. But for a lot of people, that's the kind of thing they're willing to just kind of pick up as a little fact or a little meme on its own without it being meaningful to their other political beliefs. It didn't matter that much who shared it. So there's certain things it applies to and certain things it doesn't.
Yeah. Thanks.
So Kevin, do you want to continue with your question?
Yeah, great. Thanks, Cailin. This is really, really interesting stuff. So I don't know, maybe I'll just say a little bit of a skeptical thing about the kind of like policy suggestion that you said at the end, and then ask you to maybe sort of think about like nearby policies. Because, one of the things you said is that like the best thing is for the correction to come from the same person who initially spread the misinformation, which makes a ton of sense, of course, because, the misinformation is going to spread according to the structure of the social network. So obviously the retraction will spread more or less according to the same. But, for obvious incentive reasons, that's going to be difficult in a lot of cases, right? It's going to be hard to get Ioannidis to advertise the correction of his own mistake as much as he's willing to advertise the mistake in the first place. And that's going to be broadly true for lots of situations like this. So is there any sense of like, what's the second best solution here? Like, if we can't get Ioannidis to correct himself, is there some sense of like similar, or where's the right, who should be the person that we pay to say Ioannidis was wrong or something?
Yeah, that's good. And it relates to, so in this like meta-science literature on retraction and failures of retraction, one thing people have pointed out is this exact thing. Like, part of the problem is that individuals don't want to shout it to the rooftops when their papers have been retracted. They often leave their papers up on their website with no note about the fact that it's been retracted. And journals are sort of under the same incentives. They also don't want to really widely publicize that things that they published were fraudulent or in error. And so they also don't do a lot of work to communicate like, this is a retracted thing. They will often put like a little word that says withdrawn that you can't even necessarily notice when you look at it. So I think all of that relates to this kind of incentive structure you're talking about, where people don't want to share that they were wrong. I mean, when it comes to science and scientific communities, I tend to think journals and preprint archives are the right people or the right institutions to be responsible for very widely sharing retractions, right? So although there's some incentive to hide that they made a mistake, it's not really their mistake. And part of being a responsible institution of this sort should be really owning it when you've published something that turned out, to be misleading. I'm supposed to have that turned off. Sorry. That does not usually happen. So I tend to think that we should have institutional norms saying that if you are a journal, you very clearly have like retracted in big letters across the paper. And maybe you even send out an email to everyone who's on your subscription list saying this paper was retracted. Or maybe you put into the media when there's a very serious retraction. So I think the Lancet has even done that a few times. So in science, I tend to think that's the right unit. In media, it would be also nice if the media sources, institutions were doing this too. If the Wall Street Journal had taken down that piece by Bogan or insisted it be fixed and changed the title and promoted the fixed one, that could go a long way to improving the situation. With individuals and social networks, it's much harder. I mean, you can't pay my buddy to tell everyone I was wrong about something. Oh my God. Sorry. Yeah.
Well, let me just say, I'm your buddy and I'm for sale. So if anybody wants to pay me to...
I know you'll tell everyone when I was wrong.
So next question is by Simon.
Hi, thanks for the talk. Really interesting, and I just want to say thanks to the organisers of the workshop for organising this and opening it up. It's really been a pleasure to listen to the talks today. I love this term, information zombies. Clearly a problem for democracy more generally, and not just in the scientific context. And I just wondered if you talked about the original author retracting the piece of work. You talked about the kinds of information to some extent that have more difficulty getting retracted. What about the environment? So is there anything about the general epistemic environment, the way that the network is formed, that you can point to and say, this is a better way of arranging things, arranging the broader institutions so that things that need to get retracted properly? I wonder in particular about polarized environments. You might think that polarized environments are a good place where retractions are unlikely to spread because you've got, two sides wanting to spread only one side of the story.
Yeah, good. I mean, and we didn't look at any kind of environment where you'd have proper polarization. I think this thing about homophily is relevant, where if you have homophilic environments, you both have these longer path lengths. You also can have this situation where if a retraction is introduced in the wrong subcommunity, that can stop it. It can mean it doesn't get to the right people. So ideally, what you would want is situations either where you don't have strong homophily, where you have ties between communities, or when like a retraction or refutation is, say, issued in some scientific field or some subcommunity in another space, that people repeat it in the other community where the false belief is common. But I think as you're pointing out, and I think this relates to Mihaela's comment as well, there are more things that matter than location. And one of those has to do with trust, who is a trusted source of information. And when you have polarization, you often have groups where they're homophilic, but it's not just that they're homophilic, it's also that they don't trust the people in the other group to share information with them. And so if a liberal site says Fox News was wrong about this thing, well, the Fox News viewers don't care at all about what this liberal site says, both because they're not listening to it and because even if they were, they don't think that's a trusted source of information. I mean, it points at a way of reducing polarization and improving belief. If you could get these kinds of groups to be, these kinds of sources to be willing to work together to repeat refutations that came from another camp in their own camp. But there isn't a lot of incentive for anyone to do that. I mean, there's no incentive for liberal sites or conservative media sites to be doing that, and they don't look good when they do. So.
So I had a question, but Alessandra, if you want to go first, you can.
I think my question has actually partly been answered, but perhaps I leave it to you to judge whether it has or hasn't. So one of the things I was interested is that there is a sense in which, in the scientific case, any retraction is always somewhat partial, because testimonies of its validity remain in the citation trail that that piece has left. So even if the piece has been retracted, it basically gets validated by the citations that were given before it was retracted. And they are still there. So I wonder whether that somewhat changes the dynamic, so that there are still sort of signals, right, that it was valid, that sort of keep popping in as if they were new sources, so to speak. And I wonder whether you think that is a good way of thinking about it, and if it is, then how and whether it changes the dynamics.
Yeah, I think this is absolutely a good way of thinking about it. And this is something that, we talk a little bit about in the paper and others talk about in this literature. They're not quite in the way you put it, which was very nice, which is, so the way we were thinking about it is something like, people are often drawing directly from a paper, a citation, rather than going to the original source. And we know people do this all the time. They don't go back and check the paper at the site of the journal. They read what so-and-so said about the paper, and then they take that, as you say, as testimony about the truth of this, and then they repeat it. And so that in some ways works like these kind of spreading connections in a network where information goes out not from the original source, but from a new source of information. But I think what you just brought up that's interesting to me is this idea that these citations kind of remain physically in a way that's different than what happens in other kinds of social networks. Like people can read them right now and it looks like new testimony right now. And that probably does help continue the spread of retracted information. I mean, one thing that we argue would be good, and others have argued for too, is more active checking by publishers and journals of what are the citations in this paper, and some kind of process, and you should be able to automate this potentially, that flags retracted papers that are being cited, where you then at least make sure you check in with the, author. Did you know that these papers were retracted? That would then work as a way to kind of continue the sharing about retracted information for a longer period or something like that.
So my question was about, a lot of times in your talk, you use the scientific network as kind of an exemplar for general network structures. But with those COVID examples you had, I was thinking there seems to be a stark difference between how obviously scientists think about retractions, even though there's this high incentive like journals and individual scientists to kind of play it down and maybe not be too verbal about it, and maybe we could do something there. But it seems to be very evident that obviously the general public isn't used to the scientific method, and that retractions or falsification of previous results is a normal thing in sciences. So the general public has a very different view on what that means and how to evaluate that. And basically, and that sort of bleeds into like journalism not wanting to do this because it actually undermines people's trust in science, in the scientific method, right? Because they don't quite understand how it works. So, and that is kind of an interesting thing. And I was thinking, in your model, wouldn't that be simply the equivalent of, instead of just having these two clusters like Republicans, Democrats, and then very few bottleneck connections in between, isn't that sort of similar to say, okay, the prevalence to correct with the retraction? So you had a false belief, and then you learn about the retraction. Isn't that sort of like putting a weight on all of the edges within the network? Or would there be something more interesting happening?
So can I see if I understand the sort of thing you're talking about? Scenarios where the scientific community people in the scientific community don't necessarily want members of the public to know about a retraction because it decreases trust in science. Mm-hmm. Oh, okay. So that is the correct. Yeah. And so then you see some extra unwillingness to share information across an edge. Yeah, I think you could include that in the model as, like, as you say, a weighted edge where, when these two meet, they won't share that information. But it'd have to be even more special because they're perfectly willing to share the initial scientific claim.
Exactly.
They only don't want to share the retraction.
Yeah.
And I think you're right that is a thing that in many cases it seems to have driven choices, especially by journals, in communicating about certain kinds of retractions, that they didn't want to create a kind of public uproar when it turned out information had been false in the first place.
specifically to that point, I was thinking, okay, sort of using the weights is one thing. That's sort of a simple thing to do. You have these two clusters, like one cluster represents the scientific world, the scientific network, and then the other one is the general public, and maybe regular newspapers and journalism like that is sort of the bottleneck connection between them. And then, like you said, we use these different weights. But I was thinking, with all of the aspects that you pointed out and other people have pointed out, how these different interest groups, the scientists themselves, the journals that publish the stuff in the first place and should be publishing and publicizing the retractions, and then you have the journalists who are kind of hesitant by now to sort of put out these retractions because it leads the general public to have less trust in science. Maybe we could also think of a version of this this model where there's kind of a back propagation happening, where the spreading of the false beliefs and the retractions in one direction of the network has a certain set of rules, but then there's also back propagation where the same agents now say, okay, if I am now the bad guy and I have to say within my edge of the network that I was wrong, then I have different motivations whether I'm willing to do so. And the back propagation rules are kind of different from the forward propagation rules, because maybe that's more realistic. But like we said, like using the weights is kind of similar to counting the path length. So maybe it is kind of predictable what would happen, but.
Yeah, I mean, I think in general, something that we didn't play around with because it was almost too easy was just, and this again relates back to Kevin's comment too, was just people's resistance to say they were wrong about things. You know, there's no aspect in our model where people, you know, we say like, okay, retraction kind of starts off with this asymmetric disadvantage because it's often less relevant, but it also, there's another asymmetric disadvantage, which is just that people don't like to say they were wrong.
Exactly.
And so they're often just not willing to get out there and shout like, I was wrong about this thing, turns out that was false. And if we added that to the model, I think it would be realistic to many cases, and it would be pretty clear what would happen. It would just mean that retractions would reach a smaller portion of the community across more scenarios.
Maybe with the recommendations for policies, we would arrive at suggestions like, especially the people who are at the connections of those bottlenecks where there's very few connections, those matter the most, like the journalists who sort of connect those two worlds, the scientific world and the general public. Maybe something like that is sort of the conclusions that could come out of it.
Yeah, I mean, I think like the main places we've been focusing and thinking about policy are journals and media sources for a number of reasons. So number one, because they tend to be connected to many, many people. You know, they are like the preferential attachment hubs where, you know, many, many thousands of people are getting information from them. And so for that reason, they're quite relevant to spreading retraction. That's one thing. Another thing is that they're institutions that can have rules rather than people who are quite hard to govern or convince. So there's some hope of changing what their rules for sharing are reasonably. And so those things together make them the kind of like best bets for intervention, I think.
And plus, like regular newspapers already have this mechanism established. They often publish these corrections and regular mistakes they make and reporting statistics and stuff. So people are used to sort of every once in a while at least looking at the corrections.
Yeah.
Even though the general public isn't used to the scientific method, so they're not actually, like you said, like they're not likely to go back to the original paper and look at what the author did afterwards and whether there was a retraction of the original paper and stuff like that. So, but yeah, we're running over time, I guess. Right, Michaela? We should be in the general discussion by now.
Yes, technically, indeed, we are already in the general discussion, but you know, it's part of the. I mean, yeah, technically we finished, but the discussion is so lively. But actually, I have another like small point that I was wondering about this tendency of people to cling on false beliefs and kind of be resistant to correction. If a factor like repetition of the wrong information, as it were, the false information, and sort of that creates a sort of familiarity or a sort of illusion of truth. Might that be kind of playing into
I mean, I think, yeah, I think that's, in many cases, there are further psychological things. So what you just mentioned, I mean, sometimes people call that the illusory truth effect, that if you keep hearing the same thing again and again, even if the original source of the information was the same, and so you shouldn't rationally keep updating on it, you do in fact become more and more convinced of something because you've heard it multiple times. So there's that. There's also grounding effects, which we didn't include or think about, but should be very relevant to retraction, which are these ideas that sort of like the first thing you hear in a certain domain acts as an anchor for where your beliefs go, and then everything else has to adjust or challenge that. And so if the first thing you hear is an anchor that's a false belief, it might mean that retractions are harder because you then have to move a belief that someone has settled on, rather than introducing something in a totally new arena to them.
Yeah. It'll be harder to dislodge the strength and that. Yeah.
Kind of a poignant question, Cailin. What do you think? When is the right time for COVID retractions? Are we past the point yet, or?
So that was like, obviously this is a situation where we're like, here's the thing we find in the model, but the actual policy recommendation seems tremendously dangerous. Like it seems like something that could cause real harm if you did it wrong. So we did not at all in the paper say like, yeah, and we think it's a policy that journals should delay a retraction until a lot of people have really heard about this false belief, or try to drum up interest in the false belief before they retract it. We take that more as like a thing, that might happen in real cases. And we kind of want to see if we can empirically investigate whether that does happen, but not as something that, right, we should take as a policy proposal.
Yeah, like you said, like the urgency of the issue just puts so much pressure on all of the actors involved that it does weird things to people. Like they are less cautious than they usually would. They are less hesitant to say, well, I don't know yet. Let's wait for more data. So everyone's under a lot of pressure to say something about the issue, to make a decision, to do something earlier rather than later. So I mean that, like you mentioned the scientific method, sort of the sciences being quicker to publish and stuff like that, but like I think it applies to everyone involved, not just the journalists, but also the general public. The general public, every once in a while, like every time we have these waves, people are more inclined to look at news media and news outlets and look for data and new information, and then it kind of subsides, and then people want to go on vacations, and then they want to sort of ignore it, and then it sort of comes back, the interest comes back with people, and so it sort of comes in waves, which is especially with your model being a contagion model, would be quite interesting how that all kind of affects the timing of things.
Mm-hmm. I mean, I think you also see a scenario with COVID-19 where there's some cognitive dissonance because people have to make decisions. So policymakers have to make decisions and individuals have to make decisions. And sometimes the information hasn't been there to ground those decisions well, but no one wants to say, I'm just making a guess. Like you want to have a reason for it, right? And so you're quite willing to grip on to poor information or basically anything you can get, even if it hasn't been well vetted, even if it's, not very good study or whatever.
Yeah, and also the sort of changing of the experts and sort of the perception of the public and who's the group of experts that we're relying on, and that changes. And I mean, that's been happening in a number of countries, and the general public is kind of suspicious when that happens. Like, why would you change your expert? Why are you now relying on someone else? And that, I mean, in your model, it seems fine to me, but in the real world, this has drastic differences, like where you are in the network and whether you switch from one source of disseminating retraction information or the original information to another person. Like you said, it's not just whether we should start with whether the person who originally posted it should be the one retracting it, but it's also that there are certain actors in the network that people rely on, and the kind of things we do in these models where we just pick different actors or say select them at random is kind of a trivial is a non-trivial thing in the real world, because people are kind of suspicious, like why would you rely on this expert now and then later on you switch experts, that kind of thing. So in the model we kind of just play around with this in terms of randomness, but in the real world this has very deep psychological impact on people, and all kinds of second order effects.
Yeah.
Like in the US with the election, you know that. I mean, like when Biden put together the new team and has a new group of experts relying on, and people are now sort of taking a different view, and that's been happening in Germany as well. I mean, there were some people who were very vocal in the beginning, and they put out podcasts and stuff like that, but then they got a lot of hate comments and death threats and all kinds of nasty things. You know how people are in the comment section. It's just horrible stuff. So some of these people were like, I don't want to be the expert anymore, so now they have different people, and some people are sticking with it, but usually the public perception is kind of weird when someone says, I don't want to be the expert anymore, and then they bring in someone new, and they go like, okay, so is everything wrong that the original person said, or is that a sort of retraction? Is the switching of the actor a retraction? Something that we don't necessarily reflect in the models, because we sort of fix the network structure initially, and seems to be more dynamic in the real world.
Yeah. I mean, I think in general, all these features having to do with interpersonal connections, trust, expertise, reputation, like are actually very important, and we don't even track them or consider them at all.
So thank you everyone for your excellent talks and lovely discussion. And, I feel like I learned a lot. So thanks a lot everyone for sticking around with us till late hour.